Hello everyone, welcome to Astronautics for Exploit. In this video, I will be going over solar storm, types of solar storm, effects of solar storm, and major solar storm disturbances. Solar storm occurs when a large-scale magnetic eruption, often causing a coronal mass ejection and associated solar flare, accelerates charged particles in the solar atmosphere to very high velocities. Appears as a disturbance on the Sun, which emanates outward across the heliosphere. Solar storm affects the entire solar system, including the Earth and its magnetosphere. The outer solar sphere, the corona, is structured by strong magnetic fields. Solar storm patterns are of two types: short term, which is the space weather, and the long term, which is the space climate. Space weather is the dynamic conditions in the Earth's outer space environment, in the same way that weather and climate revert to conditions in Earth's lower atmosphere. Space weather includes conditions and events on the Sun, in the solar wind, in near-Earth space, and the Earth's upper atmosphere. Space weather can affect space-borne and ground-based technological systems, human life, and endeavor. Space climate is the long-term variation in solar activity within the heliosphere, which includes the solar wind and the interplanetary magnetic field. Effects of solar wind and IMF in the near-Earth environment includes the magnetosphere of Earth and the ionosphere, the upper and lower atmosphere, and the climate. Scientific study of space climate is an interdisciplinary field of space physics, solar physics, heliophysics, and geophysics. This picture shows solar storm. NASA Solar Dynamics Observatory. A solar eruption on September 26, 2014, discovered by NASA Solar Dynamics Observatory, is shown in the picture to the right. If erupted, solar material reaches Earth, it can deplete the electrons in the upper atmosphere in some locations while adding electrons in others, and this can therefore disrupt communications. The different types of solar storm are solar flare, coronal mass ejection, geomagnetic storm, solar particle event, or solar proton event. Solar flare is an intense burst of radiation or a sudden flash of increased brightness on the Sun, which is usually observed near Sun's surface and in close proximity to a sunspot group. Powerful flares are usually, but not always, accompanied by a coronal mass ejection. Solar flares are seen as bright areas on the Sun and can last from minutes to hours. Can cause bright aurora if penetrated into the upper atmosphere, that is the ionosphere. Solar flares are solar system's largest explosion in the Sun's atmosphere. The primary ways we can monitor solar flares are in X-rays and optical light. This picture shows solar flares. A sunspot observed in high resolution by the Gregor telescope at the wavelength of 430 nm. Coronal mass ejection are massive bursts of solar wind which often follow solar flares but can occur independently. The outer solar atmosphere, the corona, is structured by strong magnetic fields and can release bubbles of gas and magnetic fields called coronal mass ejections. A large coronal mass ejection can contain a billion tons of matter that can be accelerated to several million miles per hour in a spectacular explosion. This picture shows coronal mass ejection. Geomagnetic storm, a temporary disturbance of the Earth's magnetosphere caused by a solar wind, shock wave, and or cloud of magnetic field that interacts with the Earth's magnetic field is referred to as geomagnetic storm. The most serious effects on human activity occur during major geomagnetic storms. Space weather phenomena caused by a geomagnetic storm are solar energetic particle events, geomagnetically induced currents, and ionospheric disturbances. Instruments generally used for measuring geomagnetic storm are magnetometers, electric sensors, radio senders, and particle detectors. These pictures show geomagnetic storm, the eruption of geomagnetic storm. Solar particle event occurs when particles, mostly protons, emitted by the sun become accelerated either close to the sun during a flare or in interplanetary space by coronal mass ejection source. The events can include other nuclei such as helium ions and HCl ions. Effects of solar particle events are they can penetrate the Earth's magnetic field and cause ionization in the ionosphere. They can cause energetic protons, which are significant radiation hazard to spacecraft and astronauts. This picture shows post-eruptive loops in the wake of a solar flare, and this image was taken by the TRACE satellite. Effects of solar storm. The effects of solar storm are based on the effects of solar flare, coronal mass ejection, geomagnetic storm, and solar particle event. Effects of solar flare. Effects on Earth. Soft X-rays energy increases ionization of Earth's upper atmosphere and can interfere with shortwave radio communications. Intense radio emission from flares and changes in the atmosphere can degrade satellite communications. Events on spacecraft. Solar flare can cause radiation hazards to spacecraft and astronauts. Hard X-rays energy can damage spacecraft electronics, and energetic particles from a solar flare or coronal mass ejection is dangerous to an astronaut on a mission to the moon, Mars, or beyond. It can hit the outer atmosphere and thus increase the drag on low orbiting satellites, leading to orbital decay and reduction in spacecraft lifetime in orbit. Effects of coronal mass ejection on Earth. It influences the local space weather in the vicinity of the Earth, and it can cause damage to electrical transmission line facilities, resulting in potentially power outages. Effects on spacecraft. Coronal mass ejection can trigger geomagnetic storms which can disable satellites. Along with solar flares, coronal mass ejections can disrupt radio transmissions and cause damage to satellites. Humans at high altitude, as in airplanes or space stations, risk exposure to coronal mass ejections. Effects of geomagnetic storm on Earth. Radiation hazards to humans. Although Earth's atmosphere and magnetosphere protect the ground level, but astronauts are subjected to potential leader radiation poisoning in space. Solar proton events can produce elevated radiation aboard aircraft flying at high altitudes, thereby posing risk. Resultant effect on animals. Some scientists suggested that solar storms induce whales to beach themselves, and migrating animals such as birds and honeybees, which use magnetoreception to navigate, might be affected by the geomagnetic storm. Used by geophysicists. Many surveyors use geomagnetic alerts and predictions to schedule their mapping activities. Pipelines. Pipeline flow meters can transmit erroneous flow information, and the corrosion rate of the pipeline can be dramatically increased. Erroneous flow information of pipeline flow meters and pipeline corrosion rate is thought to be caused by geomagnetic storm. Effects of geomagnetic storm on Earth. Navigation systems. During solar events and geomagnetic storms, the system gave navigators inaccurate information by as much as several miles. GNSS signals are affected when solar activity causes sudden variations in the density of the ionosphere, thereby causing the satellite signals to scintillate. Disruption of electrical systems. Geomagnetic storm can cause electrical blackouts which may threaten food productions. Electricity grid. Long transmission lines are subject to damage by the geomagnetic storm. Geomagnetic storms are harmful to electrical transmission equipment, for example, transformers. Communications. Ionospheric storms can affect radio communication at all latitudes. TV and commercial radio stations are less affected by solar activity, but ground to air, ship to shore, shortwave broadcast, and amateur radio, mostly the bands below 30 MHz, are frequently disrupted. Effects of geomagnetic storm on spacecraft. Spacecraft hardware destruction. Geomagnetic storm results in increased drag, causing satellites to slow and change orbit slightly. Low Earth orbit satellites that are not repeatedly boosted to higher orbits slowly fall and eventually burn up. Examples are Skylab's in 1979 destruction, which is an example of a spacecraft re-entering Earth's atmosphere prematurely as a result of higher than expected solar activity. During the Great Geomagnetic Storm of March 1989, 4 of the Navy's navigational satellites had to be taken out of service for up to a week. Miniaturized spacecraft systems are increasingly vulnerable to the more energetic solar particles, and geomagnetic storm can damage microchips and change software commands in satellite computers. Communications. Geomagnetic storm can damage communications satellites, especially those in high geosynchronous orbits, thereby disrupting telephone, television, radio, and internet links. Navigation systems. The Global Navigation Satellite System and other navigation systems such as LORAN and the now defunct Omega are adversely affected when solar activity disrupts their signal propagation. Effects of solar particle event on Earth. They can penetrate the Earth's magnetic field and cause ionization in the ionosphere. Effects on spacecraft. Energetic protons are a significant radiation hazard to spacecraft and astronauts, and radiation exposure from solar particle events presents a significant health concern for astronauts for exploration missions outside the protection of the Earth's magnetic field, which could impair their performance and result in possible mission failure. This picture shows space weather, that is, effects of magnetic storms from the ground to geostationary orbit and beyond. Major solar storm disturbances. In 1972, a 230,000-volt transformer at the British Columbia Hydroelectric Authority blew up during the storm of August 2nd. In 1982, a marine navigational satellite, Marex B, was disabled during a week of intense auroral activity in February of the year. In 1989, Quebec was plunged into a full-scale power blackout during the March 13 storm, which affects 6 million people for 9 hours. A transformer also burned up at a New Jersey power station. Also in 1989, the same storm in March caused a strange effect in Minnesota. They were unable to pick up their local radio stations but could hear the broadcast of the California Highway Patrol. In 1994, 2 Canadian satellites were shut down when each was electrically shocked during magnetic storms, resulting in a disruption to telephone service which lasted for months. In 1997, an American satellite, AT&T Tested 401, went dead on January 11, just hours after a coronal mass event struck the Earth's magnetosphere, causing problems with television signals, telephone calls, and part of the US earthquake monitoring network. In 2002, the Nozomi Mars probe was hit by a large solar energetic particles event which caused large-scale failure. The mission, which was already about 3 years behind schedule, was eventually abandoned in December 2003. For more information, contact Astronautics for Exploit. Thank you.